Bonjour, good morning and good afternoon, ladies and gentlemen. My name is Eiji Morimoto from Tottori University, Japan. Thank you very much for watching my short presentation today. I'd like to share my idea for data handling and adoption of precision agriculture technology for rice production. Thank you. This slide shows that our research background. These parameters are used by a farmer in their daily conversation, and it was to upload into the cyberspace here. Also, the interoperability of data between the different operations are also important. On the other hand, when the data collected separately from the farm operation, like remote sensing, is applied to the variable application, the key to success or failure is when the data is collected and when it is applied. The same phenomena might be happens in your own country. Therefore, the purpose of our research is to introduce the idea of data linkage for rice production by defining the data types that can be collected in real time during the farm operation as high affinity parameters. 2020 last year, we measured and mapped the topsoil depth variability using the rice transplanter here, and the tillage depth monitoring was collected from the two RTK GNSS units mounted on the tractor and rotary tiller, and tillage depth level operation was done by farmer manually while checking the topsoil depth map like a car navigation system. And the topsoil depth was measured at the same time of rice transplanting this June actually, to determine if there is any changing from the last year. As a result of visualizing more than 3,200 grid data points from 1.4 hectares field meshed into 2 meters square, we found that the topsoil depth varied by as much as 20 centimeters. The map in the middle here is a result of using variation map as a guide to control the topsoil depth by tilling shallower where it is deeper and deeper where it is shallower. By mapping, we can visually see that the topsoil depth is becoming average. So next, we will evaluate the variability from the site to site. Evaluated the result with a scatter plot showing here in this graph. The topsoil in 2020 was x-axis and differences between the 2 years were on the y-axis. The result indicated that almost 50% of the total operation was able to control the tillage depth as intended. As shown in the figure in the right, here we are able to see if there has been any improvement or not. We also concluded that it is important to maintain the motivation for farmers to use the data in the next several years and to accumulate the parameters that can continuously improve the affinity of the data. As my presentation, in order to redesign the data-driven agriculture, we need to investigate the data types with which we have high affinity and develop the method for collecting and analyzing them. The milkfield data set here, which is we are designing from these high affinity parameters, can be constructed for any crops. We hope this will be helpful for your promotional activities. Thank you very much for your kind attention. Ciao!